So hello everyone, welcome to my YouTube channel. In this particular video, I will be talking about optical isomerism in coordination compounds. So in coordination compounds, there are two types of isomerism. One is structural isomerism and another is stereoisomerism. So stereoisomerism is the isomerism if you have the same molecular formula, if you have same structural formula, and the arrangement of the atoms or groups in the space is different, then because of this stereoisomerism arises. So stereoisomerism is further classified into geometrical isomerism. Geometrical isomerism is cis and trans isomerism, and or in case of octahedral complexes it's facial and meridional. I will be showing you, and it will be classified into optical isomerism. Generally, we are in this particular video I will be talking about optical isomerism only, but I will show you how you will be getting geometrical isomerism in octahedral complexes. Okay, so optical isomerism, as you can see, it's related with light. So optical isomerism, the coordination compounds that we have, if a coordination compound is there, and if the coordination compound have the ability to rotate the plane polarized light either in clockwise direction or in anti-clockwise direction, that compound will be called optical active compound, or it will be called optically active, and then it will show optical isomerism. If the compound is not able to rotate the plane polarized light, then that compound will be called optically inactive, and we say it will not show optical isomerism. This is all about you will be doing in lab. So if you are in a lab and if you want to check your compound will be optically active or inactive, you just take the coordination compound, you will put it in polarimeter, and if it is able to rotate the light, then it will be optically active. If it is not able to rotate the plane polarized light, it will be optically inactive. Okay, so we can say we are having the coordination compounds. So the coordination compounds, if the coordination compound is able to rotate, which can rotate, the plane polarized light in clockwise direction or anti-clockwise direction, that compound will be called as optically active. So this is all about experimentally how you will be finding whether the compound will be optically active or not in your exam, because in exam they will be asking the total number of stereoisomers, so it means you have to count the optical isomers also. Okay, so we also say that if you have the coordination compound, so coordination compound have non-superimposable mirror image, that compound will be called as optically active. So you will check the mirror image, and if the mirror image is non-superimposable, so it's my hand, so in the mirror, like in the video, you will be seeing this you will be seeing the mirror image of my hand. So the mirror image of my hand is not superimposable on this hand, so it means it will be optically active. So you will check the mirror image. If the mirror image is not superimposable, it's non-superimposable mirror image, then it will be called as optically active. So we can say the compound will be optically active. If the mirror image is superimposable, then it will be optically inactive. Or, so the second method that I am telling you, the third method that I am telling you, it's very important. With the help of this, you will be able to do the questions. So you will check plane of symmetry and you will check center of symmetry. So if plane of symmetry is not there and center of symmetry is not there, then that compound will be called as optically active. If plane of symmetry or center of symmetry is there, then that compound will be optically inactive. So for optically active compound, you have to check plane of symmetry and center of symmetry. So plane of symmetry is very easy, center of symmetry I will tell you. So if the coordination compounds that you are having, so we are having as coordination number 4. So for 4 there are two type of geometries. One is tetrahedral and the other one is square planar. So in case of tetrahedral, you will be having 4 ligands. So the tetrahedral geometry I will show you. So this is the tetrahedral geometry. If you will check the mirror image, the mirror image will be superimposable if the ligands are same. So the ligands that you are having, there are two type of ligands. Like in this particular optical isomerism, we will be concerned with only two type of ligands. One is monodentate ligand and another is bidentate ligands. So if we have the coordination complex with 4 ligands, then in this particular case there will be plane of symmetry. There will be plane of symmetry, like one plane will pass cutting these two atoms and this will reflect this one. So the two atoms that are coming like towards you, the plane will cut them and these two atoms will reflect each other. So in case of like tetrahedral complexes, only optical isomerism is possible when we are having different type of ligands. If you have all 4 ligands as different, then optical isomerism is possible. So in case of tetrahedral complex, we can say we need all 4 different ligands. So if all 4 different ligands are there, then it will be optically active. In case of a square planar complex, so in case of a square planar complex, there will always be plane of symmetry. So I will show you how a square planar complex will look like. Okay, so I'm having this one. So a square planar complex will look like this. So this is a square planar complex and always be there, like this plane will always cut, like this plane will always be present, which will cut all the 4 atoms. This one also, this one also, this one also, and this one also. If it will cut all the 4 atoms, then the POS will be there. If POS is present, then we can say it will be optically inactive. So with the help of POS and COS, you will be checking the optical activity, or you will check the mirror image also. Like you won't be checking whether it will rotate the light or not. It's about experiments, but in exam you will be checking the mirror image or you will be checking the POS, plane of symmetry. Okay. Second type of complex you are having, which have coordination number 6. So if the coordination number is 6, the geometry that will be possible is octahedral. So for coordination number 6, we say the geometry will be octahedral. If geometry is octahedral, I will show you how octahedral looks. So octahedral is like this. So in this particular case, you are having 4 bonds, like 4 atoms or 4 ligands in one plane. One ligand will be above the plane and another ligand will be below the plane. Okay, so this will be your octahedral geometry. So in case of octahedral geometry, first you will be checking the geometrical isomers and then you will be moving to the optical isomerism. So first you will check how many geometrical isomers are possible. So for particular geometrical isomer, you will be checking the optical isomerism. So if you have all same type of ligands, so in this case with metal, all ligands are same. So if all ligands are same, I am saying all ligands are same. So if all ligands are same, there will always be one plane that will cut this atom, this atom, this atom, and this atom. If it will cut this all the 4 atoms, then this atom will reflect this atom if these 2 atoms are same. So if it is reflecting, like this atom is reflecting this atom, then it means POS will be there If POS will be there, then it will be optically inactive. So simple, using POS and COS. Okay, so if we are having, this is very famous, like it used to come in exams. I think in JEE 2025 there was a question on the basis of this kind of like this type of complex. So the complex was MA3B3 type. So if you are having MA3B3 type, you know the coordination number is 6. So A and B are monodentate ligand. So we have the ligands according to the denticity. It can be monodentate or it can be bidentate. If you are having A and B as monodentate ligands, so first we will draw the geometrical isomers. So now I am drawing the geometrical isomers. So in case of geometrical isomers, the possibility is that like you can have A in front of A, or you can have A in front of B, or you can have B in front of B. So there are 3 possibilities, and you draw all the 3 possibilities, and first you will draw the 3 possibilities. If something is like matching, then you will cancel one of the possibility. Okay, so on the basis of these 3 possibilities, we will draw these 3 possibilities. So we can say we are having A, we are having A, and we are having A, we are having B, we are having B, and we are having B. Okay, the first possibility is like this. We are having A, in front of A we are having B, we are having A, in front of A we are having B, and we are having B, in front of B we are having A. No, it's kind of same. Wait, we are having A, in front of A we are having A. Okay, we are having A, and then we are having B, then we are having B, and then we are having B. So it will be different possibility. Okay, so I will show you. So we are having one possibility as like this. We are having A will be above the plane, and then we are having another A, then we are having this one. So these 3 are like towards one face. So this is one of the face of octahedral. So they are all towards one face. So if they are all towards one face, then we will say, and these 3B are all towards one face. So we will say this geometrical isomer will be facial, or we represent it as by this face isomer. And the second one will be like this. We are having A in front of A, then we are having A in front of B, and then we are having B in front of B. So these both 2 are different. So this one is different. These all 3 atoms are on the meridonial. So we'll say this is meridonial isomer. In the short form, we represent it as MER isomer. Okay, so for this particular geometry, there are 2 types of geometrical isomers are possible. The 2 types of geometrical isomers are facial and meridonial. So out of these 2 isomers, you will be checking which one is able to rotate the plane polarized light. So you will be checking, I told you, you will check plane of symmetry or center of symmetry. So let's check in the meridonial. Okay, so if I am having this, so I will say there will always be a one plane that will cut these 2 atoms and these 2 atoms. So there will always be a one plane that will be cutting 1, 2, 3 and 4. So if it is cutting both the 4 atoms, this plane, so this is reflecting this atom, so this ligand is reflecting this ligand. So it means in case of meridonial, POS will be there. So if POS will be there, it will be optically inactive. Now coming to the facial one. So in case of facial isomer, we are having this. So let's suppose you are passing a plane. The plane that you are passing is cutting this atom, this atom, this atom, and this atom. So you know, if it is cutting all the 4 atoms, you know this ligand and this ligand is different. So it means this plane will not be passing from like all these 4 atoms. So POS is not there. Let's pass another plane. So if the plane is passing and it is cutting 1 2 3 4 these 4 atoms, then also both the 2 atoms are different. Okay, if the plane is passing like this, the plane is passing like this, it is cutting this atom and this atom. So again you can see this is not reflecting this, the plane is passing from this side, है ना? So if the plane is passing from this side, this atom should be same on this side and this atom should be same on this side. It means reflection should be there. So in this case also reflection is not there. So it means in case of facial isomer, POS is not there, plane of symmetry is not there. It means it will be optically active. So this is very important. In the last year in JEE 2025 there was a question on the facial isomer and meridional isomer, and they were asking total number of stereoisomers present. Okay, the next type of complex coordination complex I will be discussing is I'm having a bidentate ligand. So bidentate ligand means denticity will be 2. So it means it will be connected to the metal with two different two donor sites. It might be different or it might be same. Okay, so there will be two donor sites. Okay, so I'm having MAA2 and then B2. So it means for this ligand the denticity will be 2. So it means if I'm having this kind of complex, the coordination number will be 6. If the coordination number is 6, then first we will draw the geometrical isomers. How you will draw the geometrical isomers? Geometrical isomers you will draw like this. So you are having a bidentate ligand. So the possibilities are like in front of A there will be B, or in front of A there will be A, or in front of B there will be B. So these are possibilities. So you will draw the possibilities. If two possibilities are matching, then they will be same. Okay, so it means I am having A, and in front of B I am having B, and I am having A and A, and I am having A and A. So this is one of the possibility. The second possibility is I am having A and A, and then I am having A and A, and then I am having B and B. So one possibility is this one, and the another possibility is this one. If you draw the third one, it will be same. So there are two geometrical isomers possible for this particular coordination complex. So this one is like trans and this one is like cis. Both the B are on same side, so it is like trans and it is like cis. Okay, so in case of trans, so I am having central atom. So from the central atom, if I will pass this plane, so the plane is cutting this atom and this atom, I can see the reflection of this particular, I can see the reflection of this atom on this side, this atom on this side. Or what you can do, I have a bidentate ligand. So I have a bidentate ligand, this one is also bidentate ligand. I can see if they are in trans geometry, then POS will be there. So there will be a one plane like this, or another plane will be like this. That plane will be cutting this atom, and this atom. If it is cutting all the 4 atoms, then it means the reflection of this atom is on this side, then it means POS will be there. So in case of trans geometry, POS will be there. If POS is there, it will be optically inactive. I told you will just check POS and COS, optical activity is done. Okay, now come for cis one. So in case of cis, wait, we need to draw the cis. So now we are drawing the cis. Okay, first we need to make the cis. Okay, so now we can see, so this one is cis, this one is cis. So this is cis. If we are having cis in this particular geometry, so you can see these two atoms are on the same side. Now you have to pass a plane. So if you are passing a plane, if you will check the copy, it will be like this. You can pass this plane, and this atom is on this side, this atom is on this side, then POS might be there. And the problem is you are not checking the real geometry. So basically we are saying that if you are checking this atom, this one, so one will be like upside and another will be like downside. So that's the reason. Because of this A will not reflect this. Okay, so which plane you want to pass? If you are passing this plane, like if you are passing the plane that is cutting this atom and this atom, so if it is cutting these three atoms, okay, this atom and this atom, so if the plane is cutting these, okay, 1 2 and 3, okay, so it will cut only 1 2 and 3, these three atoms. So you can't see any reflection. Also, if the plane is cutting, okay, if the plane is cutting these two atoms, then also you can't see the reflection. If the plane is passing from this side, like from the middle one, from this side, also you can't see any reflection. It means POS is not there. If POS is not there, it will be optically active. So these two cases are very, very important. So you will check these two cases and you can see the POS is not there. So it means we are having optically active compound. So that's how you will be checking optically active compounds. In the exam, remember, like, try to visualize the things in 3D. Check POS and COS, planosymmetry and centrosymmetry. If POS and COS are present, then you will say it will be optically active. If POS and COS are if POS and COS are absent, then you will say optically active. If present, you will say optically inactive. Hope you will like the video. See you in the next one.